teacher.
Bye. Right, hi everyone. Welcome to another session. I trust that you're finding it quite useful. I know that I was busy with the calculus last week, but I thought that maybe now I'd deviate a little bit and just move a little bit away from the calculus and do some paper 2 work, okay? I will come back to the calculus at some stage, but let the calculus settle, let you get used to it, and then we'll carry on some more. Okay, so I think I'd like to start with trigonometry because it's a really big problem area. And I thought I would go through from scratch. So a bit of background from grade 11 and then working our way steadily through so that it goes into grade 12. It's quite a big section, a fairly difficult section for most people. And the reason why it's difficult is because it's really not normally explained too well from grade 10 already. Okay? I am, however, going to assume that you guys at least know what sine, cos, and tan are. So sine is opposite of hypotenuse, etc. All right? And what I'd like to look at is certain questions that come up in the exam, pretty much always, and that you would need to recognize and know how to do. And the first one that I'd like to do is this one. Something like this. So if 5 sine theta equals minus 4 and cos theta is less than 0, find 2 tan squared theta. And this question will say without a calculator. Okay? When they say without a calculator, you think of things like Pythagoras and special angles. Okay? This particular type of question is Pythagoras. Okay? It is a Pythagoras question. All right? It's the if this and this, find this. Okay? So it typically looks like that. There are other variations of it, but 90% of the time, this is what they ask, and that's what it looks like. If this and this, find that. Okay? We cannot find 2 tan squared theta until we have used what they have given me. Right? So we start with that. 5 sine theta equals minus 4. And we make sine theta the subject as if we were going to solve for theta, like an equation. Okay? So that's what we do. We then tick our quadrants and we say, okay, fine. Where is sine negative? Sine is negative in these 2 quadrants. We have now exhausted all the information from the first part, from the if part. And now we're going to look at that part. Cos theta is less than 0. What does that mean, less than 0? It means negative. So where is cos negative? And you tick where cos is negative. And where you have the 2 ticks, that is where you draw a triangle from the center out, and you drop a perpendicular to the x-axis. Okay, it must always look like that. This cannot go this way. It must go vertical and then hit the x-axis. Okay. Right, so we are essentially working with this angle. From the beginning, remember, naught is my starting position, so that. But the reference angle is the one next to the horizontal. Okay? We then fill in our opposite over hypotenuse. Sine is opposite over hypotenuse. Right? So this length is 4. And this length, oh, sorry, I'm talking rubbish. This is the opposite, so this is 4. And the hypotenuse is 5. Okay, hypotenuse is opposite 90, so that's 5. that is 4. We are going to have to find the missing side, which is x. Right. We're then going to use Pythagoras. Okay, so what does Pythagoras say? It says, the square on the hypotenuse, 5 squared equals, and then you add x squared plus 4 squared. You always start with hypotenuse squared equals and you add. I don't like that other off by heart learning way where you, if this, then you add, if this, then you subtract. Pythagoras said the square on the hypotenuse is equal to the sum of the squares on the other two sides. Okay. Right, so 5 squared is 25 and 4 squared is 16. And now I'm going to throw my 16 over. 25 minus 16 is 9. And if I square root, I will get x equals 3. Right, now it's actually plus or minus 3 when you square root. This x will definitely be a negative 3. Okay, but the length is 3. Right, now I'm trying to find 2 tan squared theta. Right, 2 bracket squared. Whenever I have a trig function to a power, I put a bracket and I put the power outside the bracket. And then I work out tan of theta. So if I look at my angle, my reference angle, I go tan is opposite over adjacent. So it's 4 over 3. All right. Now, tan in the third quadrant is positive. So it would be positive. Another way you can look at it is the following. You see there was a minus. The hypotenuse is always taken as positive. So that minus would belong to the 4, and rightfully so because it's parallel to the negative y-axis. This you can look at as negative 3 because it's plus minus, but it's on the negative side. Now, when you work out tan, it will be minus 4 over minus 3, which is still plus 4 over 3. And in any case, it is squared, so it will be positive. 4 squared, 16, 3 squared, 9. Okay, so that will be 32 over 9. Remember, that's over 1. Okay, when you multiply. Right, so this is a typical question that you can get. You get them throughout grade 11 and grade 12. Okay, except in grade 12, they can make it a little bit harder. All right. Okay, so this is a typical Pythagoras. If something and something, find something. Okay, right. I'd like to know if there are any questions so far. Anything anyone would like to ask? I haven't checked the chat, so there's only one message, but rather speak to me. Oh, okay. You said it's not minus 4. Aksa, what did you mean by that?
No, ma'am, I was wondering if the on the thing on the graph, is it minus 4 or 4? That's what I was just wondering.
You can look at it in two ways. You can either look at it like I did it first, or you can look at it like I did it second, where I can actually fill in the signs, okay? Because you know that tan is you're working in the third quadrant, and tan in the third is positive anyway, so it really is irrelevant. You don't really need to look at the negatives and positives. Okay, so you can look at it one way or the other, as long as you're happy with whichever way you would have done, okay? All right, I think I'd like you to try one more, and then we're going to do a more of a grade 12 one, okay? Right, if minus 2 cos alpha minus 1, no, actually I want to change this one. We change it to a 3 equals 0, and theta is an element from 0 to 180. Find tan squared theta minus cos theta. No, I want to do sine theta. Right. Okay, so that's the question. Right, so again, if and find is a Pythag question. Okay, you already know that it's a Pythagoras question. You're going to have to draw the quadrants and draw the triangle in the correct quadrants based on where you've ticked them. Okay, so let's first work with the equation. Right, I must get my cos theta on its own. So I'm going to put the 1 over to the other side and then divide by -3. So cos of alpha is equal to 1 over -3. All right, so cos is negative in these two quadrants. And then theta is between 0 and 180. So from 0 to 180 is here and here. That is where I need to draw my triangle. Okay. Right, there's my reference angle. Cos is adjacent over hypotenuse. Right, adjacent. Hypotenuse we always take as positive. So the negative would be with the 1. It's on the negative x-axis. And then you're going to do Pythagoras, which you can do for me quickly. Right, so I want to find my y. So it's the square on the hypotenuse equals the sum of the squares on the other two sides. So 9 equals y squared plus 1. I'm going to throw the 1 over. 9 minus 1 is 8. And then I'm going to square root. So that's root 8. And remember, it is plus or minus. I need to decide if it's plus or minus. It's definitely parallel to the positive y, so it is positive root 8. Okay, and your aim is to always have all three sides. Once you have all three sides, you can then go and find what they are asking you to find. Okay? Right, so the tan of theta is opposite over adjacent. So it's going to be root 8 over 1. And I'm going to square it. Remember, when it's squared, put a bracket squared and then work out tan in the bracket. Then you're going to square it. Then sine of theta is opposite over hypotenuse. So root 8 over 3. And then all I need to do is simplify that. Okay. Root 8 squared is 8 over 1. And then I can do an LCD. Okay, so the LCD is 3 times by 3, so that will be 24 minus. And by the way, root 8 is 2 root 2. If you put that in your calculator, root 8 equals, it will give you 2 root 2. And then you can take out a 2 and you're left with 12 minus root 2 over 3. That unfortunately doesn't cancel, so that's as far as you can go. Right, there's nothing else you can do to that. Right, any questions so far? Right, okay. Right, so the next one I want to do is a little bit different. Okay, I need to think about it carefully. Okay, so if cos 2 theta is equal to, let's make it 5 over 6, and sine theta is less than 0, find I've got to be careful now what I do. Find cos squared theta. Right. Now, this is a metric type one. Why? Because it has a double angle in it. Right? Oh, and by the way, I need to make that a 2 theta as well. Right, so we're going to go about it in exactly the same way. We look at it, if and find. We know it's a Pythagoras question. We know we're going to draw the quadrants and tick the quadrants. So cos is positive, first and fourth. Sine is negative, third and fourth. So we are working in the fourth quadrant. Remember, that is how you sketch it, from the center out, and then vertical, so it hits the x-axis at 90 degrees. That is my reference angle. Okay. And my reference angle now has to do with 2 theta, not theta, 2 theta. Okay. Right. And cos is adjacent over hypotenuse. Adjacent is 5, positive x-axis. Hypotenuse is 6, which is always positive. And in any case, it was a plus in front. Okay. And I now know that I need to find my y by doing Pythagoras. Okay. So the square on the hypotenuse equals the sum of the squares on the other two sides. And then I rearrange. 36 minus 25, I'll throw that over. And then y squared is equal to 9. Is it? No. 11. Let's check my algebra, please. And then square root. So y would equal plus or minus root 11. And you need to decide if it's plus or minus. It's parallel to the negative y-axis, so it's negative root 11. Right, and now I need to go and find cos squared theta, not 2 theta. Cos squared theta. The problem here is that this angle is not the angle that was used to construct this triangle. This was a 2 theta angle. So what you're going to have to do is think of the double angle formula. So cos 2 theta. Does it not have an option of 2 cos squared theta minus 1? Right? So now I probably shouldn't have used, I should have probably changed it to sine squared, but I'll do that just now. Right, so I want cos squared, so I must make cos squared the subject. So I'm going to throw the 1 over. So it's 1 plus cos 2 theta over, you took the 1 over, and then you're dividing by 2. And that will give me cos squared theta. And that's what I want, cos squared, which is now that. So it is 1 plus. And cos of 2 theta is adjacent over hypotenuse. It happens to be that. And you will square it, and that will be over 2. So we're literally using an identity here. The double angle formula for cos 2 theta. Then I'm rearranging it to find what I want. That's why I use this combination, because I need a cos squared. And then I take the 1 over. This keeps looking like an 11. You take the 1 over and then divide by 2. And then it's 1 plus, and the cos of the angle is adjacent over hypotenuse, which is, it's not squared. It's just cos 2 theta. So it's just the cos. So it's just plus 5 over 6. There is no square there. Sorry about that. And then you do an LCD or you use a calculator. So it will be 11 over 6. And you're dividing by 2 over 1. So you times by 1 over 2. So your answer will be 11 over 12. Okay. Sorry, this is not squared. It's cos 2 theta, and the cos of the angle is adjacent over hypotenuse. Okay, it's not squared. There's no square there. Over 2. I'm trying to find cos squared. Okay. They could have asked you for sine squared theta instead, okay? And let's do that. So if I hadn't asked you to find cos squared theta, if I'd said you find sine squared theta, you would have still used the double angle formula for cos, except you would have used this one, this version of the double angle formula for cos, the one with the sine squared. And then you would make sine squared the subject. So 2 sine squared theta equals 1 minus cos. I'm just rearranging. And then divide by 2. So 1 minus cos 2 theta over 2. Right. Oh, sorry, I left my square out. 2 sine squared. And that's what I'm saying. Find sine squared theta. And all I need to do now is just sub in. So it's 1 minus cos is adjacent over hypotenuse over 2. And then again, I can simplify. That would be 1 over 6 times 1 over 2. So in other words, 1 over 12. Okay. Right, so they can give you something like this where you actually need to use, you know, these compound angle formulas or double angle formulas at some point. And there's another one that I want to do that uses compound angles. Right, any questions? No. Okay, cool. Right, what about this one? If tan x, if 3 tan x plus 2 equals 0, when cos x is greater than 0, and if minus 2 cos y equals 1, when sine y is less than 0, find, and I hope I'm thinking correctly about this, find sine x plus y. Okay, so in this one, there's an if and an if and a find. So that you're actually going to do 2 different triangles, one with an angle x and one with an angle y. Okay. Okay, and then you're going to find sine x plus y, compound angles. Okay. All right, so if I start with the first lot of information, just let me highlight this. It's this, right? 3 tan x plus 2 equals 0. So if I rearrange it, I get tan x equals minus 2 over 3. Tan is negative there and there, and cos is positive there and there. So I'm working in the fourth quadrant with my angle x. This is the triangle for the angle x. That is x, right? I obviously need to fill in my sides, opposite over adjacent. So tan is opposite, which would be negative 2 because it's parallel to the negative y-axis, and then over adjacent, which is positive 3, positive x-axis. I then need to find my h. So square my hypotenuse equals the sum of the squares on the other 2 sides. So 9 plus 4, h squared equals 13. So h equals plus or minus root 13, but the hypotenuse is always positive. Right, so there we go. I have root 13. I'm now going to do the same for this information. Okay, so minus 2 cos y equals 1. Hi. You want to ask something? All right, so we're going to rearrange this one. So cos y equals 1 over minus 2. Okay, so that's adjacent over hypotenuse. Right, so if I draw my sketch, cos is negative here, and sine is negative here. So I'm talking about this quadrant, where that is my angle y. Adjacent over hypotenuse is 1, but it's negative 1, and hypotenuse is always positive. So I've put the minus with the 1. The hypotenuse is, I've put the minus with the 1. The hypotenuse is always positive. And then I'm going to find my y. So the square on the hypotenuse equals the sum of the squares on the other two sides. Right? So y squared equals 4 minus 1. That's 3. And if I square root, I get plus or minus root 3. And I can see that this is parallel to the negative axis, so it's negative root 3. Now the fun begins, because now I need to go and find sine x plus y. I do not have a triangle with an angle x plus y. So I have no choice but to break this up into compound angles. So sine x cos y plus cos x sine y. And then sine of x, this is the triangle with the x, sine is opposite over hypotenuse, minus 2 over root 13. Cos of y, this is the y, cos is adjacent over hypotenuse, so it's minus a half, plus cos of x is adjacent over hypotenuse, 3 over root 13, and then sine of y is opposite over hypotenuse, minus root 3 over 2. Right, and then I just need to tidy it up a bit. Okay, so this will be plus, the 2's will cancel, and I'll get 1 over root 13. Plus times a minus is a minus 3 root 3 over 2 root 13. And technically, I could also then go and do an LCD, right? The LCD would be 2 root 13 times by 2, so it's 2 minus 3 root 3. And that would be my final answer. Okay. All right, so there's a lot going on here. Do you see that? There's plenty going on, okay? You've just got to keep your wits about you a bit. All right. Right, any questions? Anything anyone would like to ask? I'll just check in the chat again. Okay. Alicia, right, can you explain it again? Okay, cool. Just clarify for me which one. The first one, or this one that I'm doing now, or a previous one? The previous one. Okay, let's go back. Right. Okay, so let's go through this again. I'm giving you cos 2 theta equals 5 over 6. I'm giving you sine 2 theta is less than 0. So that's negative. I know that cos is adjacent over hypotenuse. Okay. The adjacent to the angle over the hypotenuse. Okay. Cos is positive in the first and fourth. Cos is positive in the first and fourth. You tick them. And sine is less than 0. Sine is negative in these two. So this is where the 2 ticks are. That's why my triangle in this quadrant. Okay. I then fill in my adjacent and my hypotenuse, and then I need to work out my opposite. So I can do my Pythagoras. I think what I'm going to do is I'm going to do this one again so that you've got all the working out. Let's just do it again from scratch. Okay. And I'm actually going to just do finding sine squared theta. Okay. All right. Okay. So cos is positive in the first and fourth, and sine is negative in the third and fourth. 2 ticks. So this is where I draw my triangle with the 90. That's my reference angle, right? Adjacent is 5, hypotenuse is 6. Then I do Pythagoras to find y. Square on the hypotenuse is equal to the sum of the squares on the other two sides. 36 minus 25. So y squared equals 11. And then I square root. So y equals plus or minus root 11. Okay. It is minus root 11 because it's parallel to the negative y-axis. Right. And now I need to find sine squared theta, but this is a 2 theta angle, not a theta angle. So I can't use things as they are. I can't just go and find sine of 2 theta when it's sine of theta. Okay? But I know that the cos of 2 theta is equal to 1 minus 2 sine squared theta. Right, I know that. Okay, so I can use it. Right? In order to find sine squared, I need to make sine squared the subject. So I'm going to bring it over and keep the 1 and throw that over. And then divide by 2 to get rid of it so that I only have sine squared. And then all I need to do is substitute the value of cos 2 theta in. Cos of that is adjacent over hypotenuse. Okay, so it's 5 over 6 over 2. Right? And 1 minus 5 over 6 is a 6th. And you're dividing by 2 over 1, so times 1 over 2. So it's 1 over 12. All right. But you most certainly start with the whole Pythagoras thing, ticking the quadrants, sketching the sketch, filling in the sides, working out the remaining side using Pythagoras. Okay. Right. Any questions about that before we carry on? Is that okay? Okay, super. All right. Okay, and then let's go through the second one as well. Oops. All right. I'm not going to rewrite this one, but all right. So I give you 2 lots of information now. So I have to do this for one triangle and then another set of information for the other triangle. Okay. I see I wrote when with a D at the end. I don't know why I would do that. Okay, so we rearrange. So tan x equals minus 2 over 3. Tan is negative in the second and the fourth. Cos is positive in the first and the fourth. So I'm working in the fourth. I draw my triangle and I fill in my sides. Opposite is minus 2 because it's parallel to the negative y-axis. And over 3 is your adjacent. Opposite over adjacent. And that is the positive x-axis, so it's positive. And then I do Pythagoras to find h. Okay, so h squared equals that squared plus that squared. It ends up being 13, I square root, so it's plus or minus. but the hypotenuse is always positive. Okay, so now I have all three of the sides in the x triangle, the x one. Now I'm going to do the one for y, a separate triangle, because it's now angle y. Okay, so I rewrite and I rearrange. 1 over minus 2. That is adjacent over hypotenuse, right? Cos is negative in the second and third. Sine is negative in the third and fourth. The two ticks are in the third quadrant. So I draw my triangle and I fill in my adjacent and my hypotenuse. My adjacent will be -1, it's on the negative x-axis. So the minus actually belongs to the 1, and the hypotenuse is always 2. And then I'll do my Pythag again. 2 squared equals √3 squared plus y squared. Oh, goodness, sorry. 2 squared equals y squared plus -1 squared. And I simplify and I get √3. And it's plus or minus, right? But it's here, so it's on the negative y-axis, so minus √3. So if I now want to go and find sine of x plus y, there is no triangle with, none of these triangles have an angle x plus y. I have an angle x and I have an angle y. So I need to break that up, and that's why I use the compound angle formulae, okay? So sine x cos y plus cos x sine y. And then I go and work out sine x and cos x in the x triangle and cos y sine y in the y triangle. And all I do is I substitute them in and simplify. Okay. All right, so sine of x is opposite over hypotenuse, -2 over √13. Cos of y is adjacent over hypotenuse, plus cos x is adjacent over hypotenuse, 3 over √13. Sine y is opposite over hypotenuse. Right, so √3 over 2, well, minus √3 over 2. Okay, and then you simplify that. Right. Right, any questions? So I've gone through both of them. Those are the harder type of Pythagoras questions that you could get. All right. I'd just like to check if there are any questions. None left? Okay, cool. And there's just one thing I want to do with you. I'll touch on it and we'll carry on with it next time, okay? They love asking these, okay? So they'll give you something like this. If I just have to think carefully now. If cos 30 equals A, find, and then they'll ask you something like, find sine of 150, for example. Okay, so they're giving you this, so this is what you need to work with. Cos 30 equals A over 1, so you're going to do a triangle. You don't know if it's plus or minus because you don't know what A is, so you just draw any triangle. You call your angle 30, whatever they said it is, and cos is adjacent over hypotenuse, so adjacent over hypotenuse. And then you work out your remaining side, in this case y. So square on the hypotenuse equals the sum of the squares on the other two sides. I'm trying to find y, okay? So y squared equals, if I leave it there, I throw that over. So 1 minus a squared. 1 squared is 1, right? And then I square root, because I want y. So y is equal to the square root of 1 minus a squared. That is what's there. Right, so now I go to my question, and I see that I have an angle that is not acute. So remember, you need to reduce it. Where is 150? Second quadrant. What is sine in the second quadrant? Positive. Sine 180 minus, which is 30. Remember, you always need to reduce it to an acute angle. All right. And the sine of 30 is opposite over hypotenuse. Okay? So it is going to be root 1 minus a squared over 1, which is just root 1 minus a squared. Okay. All right. So you must reduce. And at this point, you need to use the triangle where you have found the missing side. So in a way, it's like a Pythagoras question. All right. And there's just one more that I'll squeeze quickly. Something like cos 60. Now, this triangle does not have a 60. So you can't use the triangle to find cos 60. But what you should notice is that 60 is 2 times 30. In other words, a double angle. So in other words, cos 2 theta equals, what does it equal? 2 cos squared theta minus 1. Where theta is now 30. Right? So in other words, it's going to be 2 cos 2 theta is 2 cos squared theta. So cos squared 30 minus 1. Remember, when I have a square, I put a bracket, and then I work out the cos of 30. Cos of 30 is adjacent over hypotenuse. A over 1 is A. So my answer is 2a squared minus 1. Right, this question will say, writing your answer in terms of A. In other words, your answer will have A in it. Okay. Right, these are, I'm squeezing this in quickly. I'm rushing a bit through it just to cover it for the sake of covering. I'm going to definitely do more of these. Okay, they're quite popular questions. Okay, in an exam. All right. So just remember, if you get given something like this with an unknown, just draw a triangle. Fill in the sides, like you do with the Pythagoras questions. Work out the remaining side, but the answer will obviously have a variable in it, like this one had A in it. And then whatever they ask you, you have to try and get it back to a 30. This happened to be easily back to a 30. So you could just use the triangle. Different story here. This is a double angle. So they could have asked you this last year. They could not have asked you this last year because it's not in the grade 11 syllabus. Okay. Grade 12 syllabus, double angles. Okay. All right. I just wanted to get that in quickly. So awesome. I'm going to stop there. Thank you very much for joining. I hope that made sense. You can always go and look over it again. Okay. Yeah. See how the week goes. And I'll definitely carry on with trigonometry on Monday. Thank you, guys. Bye. Cool. Bye.